It's a bit of a surprise to me to find myself here because, as you said, I'm a quantum physicist and I work in the overlap with general relativity, but I haven't really ever addressed the question of consciousness, and I'm here because Roger Penrose invited me to join as a founding member for the new Penrose Institute because of my proposals to use quantum systems to measure gravitational effects, which might have let's say, which might be relevant for what he's thinking about, which he hopes to explain consciousness with. But it has a funny story to it, actually, because when I was a high school student, I had very clear what I wanted to do with my career. So I knew that I wanted to understand how, from the interaction of atoms or molecules or neurons, thought emerged and consciousness emerged. I had that really, really clear as an 18-year-old. And I went around asking people, what do I have to study to understand this question? And well, in spite of my aunts being psychologists, and I had an uncle that was a doctor, my father himself studied physics, nobody could point me in the right direction, same teachers. So I eventually gave up, and I said, well, okay, I'll study physics, because that's interesting enough. And then I did a PhD in quantum information. And once I finished my PhD and I was about to give a public lecture, I was preparing the lecture. I was trying to explain to people what information processing is, and I gave as an example the brain. I said, in neurons, they, talk to each other, and this is how thought is generated. And then I realized that I had learned something, which was quantum information processing, and that if there was quantum effects in the brain, and I thought, well, why not? It would actually be quite cool. Then maybe what I've learned will be applicable to that question that I had when I was 18. So I got excited about that, but of course I didn't do anything about it because I had already started to follow another path, which was to understand the overlap of quantum metrology, quantum information with general relativity. And then I met Roger Penrose some years after, and he got very interested in my proposals. And then it turns out that he invites me to join the Institute, and that the Institute is about consciousness. And I was like, this is so funny how, life can go around circles and you end up right in front of what you wanted to do.
Anirban, we're familiar with your microtubules research, but now you've got a model. Tell us what's going on here.
Yeah, so this is a tubulin protein.
That's a model of the tubulin protein?
Yes. So this is created by the son of J.D. Pokorny, Jan Pokorny. So we have 15% of our body is made of this particular protein. So if we go in the brain, majority of the protein is this. This is the unit of here. So this is microtubule. Each capacitor actually represents the entire structure. So inside a neuron, we have this kind of nanowires. So we have built two of them. One lattice is here, another lattice is here. What we are doing, we are pumping noise. And what is this system? This system is like this. Okay, so this is just like this. So we have capacitors soldered in a ring. But we follow the exact topology that is there in the biological system. The distance between these two and distance between these two, if we take a ratio, it is 1.03 in every single protein in the living plants, in life forms, everywhere. So we have followed that exactly, and we have created two lattices. We have pumped noise, and this generates organized signal in the megahertz domain here.
So by building a scale model of the tubulin and the microtubule, then by pumping noise into it, you're showing that, like what happens in biology, that the system can use noise to produce sort of organized behavior.
Yes.
Awesome.
So it's my great pleasure and honor to welcome to Consciousness Central Dr. V.S. Ramachandran, Distinguished Professor at UCSD, acclaimed and renowned neuroscientist. Welcome.
Thank you. I'm pleased to be here.
Thank you for coming. And can you just give us an outline sketch of your work and how it relates to consciousness studies here?
Well, part one is easy, outline sketch of my work. Part two, about relating it to consciousness, is a tough one. In terms of consciousness, the word is used in many different ways, as you know. Mind, consciousness, qualia, self-awareness, sense of self. And I think there's confounding two problems. here. One problem is what I call the vantage point problem, first proposed in the Upanishads in the first, second millennium BC, and then revived by Erwin Schrödinger, the great physicist. That refers to the fact that in physics and in science, you have a third-person description of the world, an objective description of events in the so-called real world out there. And the first-person singular, I, does not exist in physics. There are billions of brains, all of which are viewing the world, of which I am one. I have no privileged status. I'm not looking at the world through windows and illuminating this corner of the world. All that doesn't exist in physics. But we know it's true. It's axiomatic that I exist and I open my eyes and see the world. And the consciousness illuminates this corner of the world, not some other corner of the world. So this fundamental asymmetry in nature between the third-person description of the world, which does not include the pronoun I, it doesn't exist. This is not verbal gymnastics. I'm saying it just doesn't exist in physics, right? Whereas from my personal point of view, that's all that exists. The world I became aware of the world when I was born, and it was going to disappear, for all I know. So this asymmetry is fundamental to understanding consciousness, but that's loosely analogous to what Chalmers calls the heart problem. And that, I think, is not going to be tackled by empirical neuroscience, doing clinical work on patients, or by doing cellular neurophysiology. It may require a complete upheaval in our view of the cosmos, of the kind that Einstein did for relativity or quantum mechanics. You need a completely different conception of the cosmos, integrating the mind into it. This is what people like Roger Penrose have suggested. You need a new physics, in other words, because physics, science as it stands now, does not include the first person. Therefore, you can't explain the first person and qualia, but qualia also arises in the first person singular. I mean, I see it red. I don't know anyone of you here can see that thing, that color which I'm seeing. I just guess that you are, I infer that you are, by analogy, but I don't know for sure, because I'm sure indubitably that I'm seeing that red. That question does not arise in science because I don't exist in science. The pronoun I doesn't exist. Therefore, you can't use science to explain qualia. It's a misguided enterprise. You need to change science in some way, which we don't understand, have a new science, and that in turn might encompass qualia. So that's one view.
Hello, Consciousness Central. This is Nama Costiner, and I'm presenting here about the sensation of flow that we get in creative processes. So I've been lecturing 2 times, and these are parts of my works. These are some of my interviewees, actually, and they're active artists that create in flow. And as I was interviewing them, one of the interesting things that happened was that I found myself in a state of flow, asking them questions about flow. So we sort of created a bit of trio here where I was documenting them in their regular works and then also using some of my own interpretations to point them out the way I saw them through the interviews. What we get here is basically narratives that can be useful in the studies of happiness, treating people with depression, because what we get out of this is actually what helps people be in flow of happiness. And if we can interpret that into the works with some mentally handicapped people, well, that's the whole idea of feeling fantastic. And thank you very, very, very much. You could take a look at the works.
This one?
This one? Okay, so this guy is actually an acrobat. He works at the circus. And as I was interviewing him, he told me that he feels a bit contained in the circus. He only feels in flow when there's audience. He doesn't really, he doesn't engage in speech with them, but he engages, through the energy, through the ambience in the room. And so he really wanted to do something urban. He says that when he's in the city, when he sees people, he feels more in flow. So my interpretation was to take him to an urban space. And since he's already flying, we put on a bird mask here. And we let him be in the ports. And then we just used a little town inside of a shopping center. We just used a little water fountain over there. We got permission to basically give him a bird bath inside of the mall, inside the fountain. So he's having a bird bath over there. And of course, in my talks, I also show serious photos of them when they're actually practicing and doing their work. So this is sort of like a metaphor on what we're all doing here. Thank you so much.
My name's Elaine Chu. I'm your pianist for this evening. And I'm from London, where I teach at Queen Mary, University of London, at the Centre for Digital Music. And I'm going to play you a couple sets of pieces. The first set, if you were at my talk, I talked about a computer program called Morpheus that would compose music based on template pieces. So it would copy the repetition patterns and the tonal tension profiles of existing template pieces, and it's optimized to, as closely as possible, follow those with random notes that are iterated and changed until they fit as well as possible those profiles.
What is it that you found coming to a conference like this and thinking about perhaps more about consciousness? Does that inform your work on linguistics in any way to begin with?
The point of convergence that interests me particularly has to do with the phenomenology of consciousness. The traditional view of consciousness was that regarded it as inner-directed. So the primary concern of the study of consciousness in the 17th, 18th century, early days of modern science was the inner life. To what extent are we aware? What's the nature of our awareness of our inner life? That raises all of the, by now, familiar questions about, what is it like to, and so on. What is it like to see this color blue? What is it like to have the thought so and so? It's the same kind of questions. But it's a rich area. In many respects, I think, a richer area to investigate than the phenomenology of external consciousness, say the color blue. It's a more complex internal system, and we can say a lot about its nature. And I think when you look into it, you find some surprising things. For example, in the case of language, which is kind of the core of our mental life, what basically differentiates us from other animals. I think you find that the internal system of language is basically a system for generating thoughts. And that system is disconnected from both consciousness and the externalization of it to the outer world. So there's things going on in our mind, and you can sometimes externalize them in one or another sensory modality. We usually use speech, but sign is about the same. It's even possible to use touch, like Helen Keller, for example. But the internal workings of the mind are inaccessible to consciousnness.
One thing I have right here to ground us a little bit, this is it's a sample, rock sample from the northwest of Australia, and it's one of the best preserved, it's really the oldest, best preserved evidence for life on Earth, 3.5 billion years old. And these little red nodules are called stromatolites. And they're biofilms laid down by early microbial communities that cement sand grains together. So this is our common ancestor. This is the unit that led to basically the entire biosphere. And this is at 3.5 billion years ago. The origin possibly was at 4.2, 4.3 billion years ago. That's the era that I work on, and there's no rock record. So these are complex little fellows. They're doing photosynthesis, they're doing chemosynthesis, probably thousands of species that made these structures. And then about 800 million years later, we find stromatolites at lake shores. So this is what's called lacustrine stromatolite, and these ridges here, those are made by living forms. And this is basically mudstone. You can almost even see it. So this is from the Tumbiana, also in Australia, and it's just basically a muddy lakeshore. And you find a lot of these preserved from the marine seashore. So this is the whole story of life for about 90% of Earth's history. And we as complex life are extremely late in the game. And we're not, our bodies are almost like microbial mats because our gut bacteria are 100 trillion of those versus 13 trillion cells. So we're mostly these biofilms.
So I thought it was important that we would be doing things which were testable experimentally, and if not, well, in reasonably near future, and perhaps with not too expensive experiments. Also, the consciousness issue is only a very small part of what I directly do myself. I mean, there's the idea, which clearly is something, well, consciousness is a subject of great importance, so if one can make progress in understanding what it is and how it comes about, is certainly something well worth studying. And if there are certain approaches to that which can be tested experimentally, I think that's important. But as far as my own work has been concerned, although the quantum mechanics end of the consciousness issue has been something I've been very interested in, it's only, again, a part of the things that I think are important to study, and that we should be thinking about various issues in physics which are not directly the ones that have been just mentioned. But again, I felt, for example, things like quantum gravity, where there are many, many ideas and theories about it, most of these are completely untestable. So I was not wanting to have something like that which would be, again, untestable. So we need things where there are experimental tests, although myself, I've not been particularly involved in experiments. So I thought, in particular, there's a lady called Yvette Fuentes, who I've known for quite a few years, and she has some extremely ingenious ideas about experiments, particularly detecting of gravitational waves, but also we talked together about how one might make experiments to detect whether the quantum state reduction that's required for the consciousness program that Stuart Hameroff and I have been trying to develop. The limits on quantum mechanics are things which could be tested. There are experiments at the moment who've been trying to look for this effect, but the idea, based on what Yvette has been doing, would be that one could use these things called Bose-Einstein condensates. That's what she's been working with for the gravitational wave detection. It's a remarkable thing what she's doing, because one knows the excitement today about the LIGO project, which seems to have detected gravitational waves from the inspiraling and swallowing up of two black holes. They spiral into each other and swallow each other up, and in the process they emit these waves, gravitational waves, so the oscillations in the gravitational field, or in space-time structure basically, and they're very, very tiny effects which have been observed just recently within the last year or so, But she has this idea that you could do it with these very, very tiny objects instead of the many, kilometer long arms which they need for the conventional mechanisms. But it did seem that these ideas could be used in other ways, not just for detecting gravitational waves, but for testing the quantum state reduction thing. And also, since I was talking to her, it seemed to me there are other things one might detect. In particular, according to a scheme of mine to do with cosmology, dark matter, which one of the great mysterious, it's the major contribution to the material content of the universe, but it's completely invisible. It seems to interact with things in no way other than gravitationally, and nobody seems to know what it is. But in the scheme I have, it has a particular, we know what it is in the context of this theory, and we also know that it should decay from time to time. And these decay products are things that probably could be detected by these same detectors.
Tell me a little bit about quantum computing and how it relates to consciousness.
Well, that's, of course, a big question. And if you came to my talk at the Consciousness conference last year, I had actually a slide that started, what can we learn from quantum computing about consciousness? And the answer was not much.
Not much, okay.
Unfortunately. There are certain other aspects that we care about when thinking about the human brain. For example, what is creativity? That is a much easier question. And there, I think we bringing in quantum elements can lead us to designing systems that might very well be the most creative systems imaginable.
Mm-hmm. Actually, that's a very interesting, let's go there straight away, because if I hear you say describing creativity is so much easier, it sounds like that's quite an achievement in itself. So how is describing creativity easy? And how do we describe creativity? And what are we talking about when we do that?
So first of all, of course, we have to subscribe to a common notion of what we would call creative. I think a pretty good formalization of creativity is thinking of it as an optimization problem. And an optimization problem is often best visualized as a landscape where you have to find a low point in this landscape. So let me illustrate this some more. Let's say an architect. We look at the work of an architect and we ask, is this a creative architect? We would typically use this term if we look at the building the architect designed, and this building is beautiful. Of course, that assumes that we can subscribe to some common standard there, but then there are more objective constraints also. Did the architect do this within a certain budget? Did he do this within certain constraints? You need permits. Did he build it in a certain timeline, and so on? So there is a long list of constraints he had to fulfill in order to create a building that just fits all these constraints.